Hello, we are here with Steve McGaugh from Case Western Reserve University. I want to thank you for taking this interview with us.
I'm happy to be here.
Our first question is about dark matter. Do you believe that it can be substituted by another physical concept?
Can dark matter be substituted by a different physical concept? I think it is possible. The use of the term dark matter is something we've become familiar with, but really what we see in the observations is a discrepancy between what we see and what we predict from what we see using Newtonian equations. So the same equations that work very well in the solar system do not work for galaxies, at least not apparently. If we assume that those equations are correct, then we are forced to infer the existence of dark matter. But really all we know is that there is a discrepancy. So it could be that there is missing mass that we call dark matter. It could be that there is some more general form of the equation that we need to use.
In your talk, you presented this new modified dynamic. Can you explain us what is it about, and does it imply that Newton was wrong?
The modified dynamics that has been discussed largely is the idea of Modi Milgram, an Israeli physicist. And he hypothesized maybe the discrepancies that we see are not caused by dark matter, but are instead the fault of the equation. And so he sought for a formula that could be applied to explain the same phenomenology that we observe in galaxies. And so the notion that he came up with is called the modified Newtonian dynamics. And the critical idea here is that the equations of Newton are correct in a certain limit, the high acceleration limit. But when you go to extremely low accelerations that we observe in galaxies, that there's a more general expression. And so you modify the equation, you get a new force law, and that is the cause of the observed discrepancies rather than the dark matter. That's his hypothesis.
Our last question is about the workshop. Do you believe it's providing new evidences against dark matter?
The workshop we're currently attending is providing evidence, I think, both in favor of dark matter and in some cases against dark matter. There's a lot of new data being presented that one has to think about and process mentally before coming to a full conclusion about. Other discussions we've had have been about old things that are well known. And I think right now we have a tremendous dichotomy. There are certain kinds of data, I think, most especially the cosmic microwave background, that really favor the traditional dark matter interpretation that we've come to light. On the other hand, the results that I showed confirm many of the predictions that were made by Milgram's modified dynamics, and so the natural interpretation there is it's really a modification of dynamics and not dark matter. And those two things are contradictory, and I don't really know how to weigh the evidence one way and the other. Here at the workshop, we've heard a number of new things, some of which I would put in favor of dark matter, and some of which I would put in favor of the modified Newtonian dynamics. So I think we live in an interesting time.
The battle is still on.
It is very much still a thing. And this is the great thing about science, is that there are fundamental things still to be learned that we do not yet understand about the universe.
I thank you again, Professor, and wish you a pleasant continuation.
Many thanks. My pleasure to talk to you.